Hi there, welcome back to this channel. In this video, I'm going to take you through chain rule case 2. Chain rule case 2. In our previous lessons, we did the case 1, so we are continuing from here, which is case 2. I have a problem here to clearly explain case 2 to you. So in the case 1, we saw that we had a function of, let's say, xy, but each of the variables within this function were also functions in itself. Okay, so x was, let's say, g of t, and y was also h of t. In this case 2, so this is for case 1. So in the case 2, the difference is you have a function of xy, all right, but x will be a function of two variables, let's say g of x and t, and y will be of two variables, h of s and t. So now we are having a function of two variables where each of the variables are also functions of two variables. You get it? So this is the main difference between the case 1 and the case 2. So let's solve this problem to see how best you understand the case 2. So now let's see. Find the z on the s and the z on the t, right? So right now we are finding the partial derivatives of the main function. Partial derivative on the main function, right? So let's find the z on the s first. The z over the s, right? So I'll move straight to the main function. As I said, whenever you want to find derivative with respect to s, where the s itself may be a function on its own, then how do we do that? So let's see. We want to find the z on the x, right? The z on the s. But where is s? As I said, where is s? S can be found in what? R, and can be found in what? Theta, right? Meaning that we can only find the z on the s by getting access to r and getting access to theta. How do I get access to s? Sorry, how do I get access to r? Simply by differentiating my major function with respect to r. And if I want to get access to theta, I'll simply have to differentiate my major function with respect to theta. Then I get access to theta after I differentiate my theta with respect to t. That is it. So as I'm saying, the z on the s, we can find it by what? Locating what? R and theta. Then we differentiate each of them respectively with respect to what? S. So I want to locate r now, so I have the z over the r multiplied by what? The r over the s plus the z on the theta multiplied by the theta on the s. And now we have access towards our ds, right? That is it. From here, we find the respective derivatives. What is the z on r from here? If you have z is equal to e2r sine 3 theta, I want to differentiate with respect to r. Once we are differentiating with respect to r, theta here becomes a constant. We only focus on here, and this one is an exponential function. So I'll simply get 2e to the power of 2r sine 3 theta, right? So I'll simply have 2e to the power 2r sine 3 theta multiplied by the r on the s. So when I come to the r on the s, so my r is also equal to st minus t squared. So if I want to differentiate with respect to x, any t here becomes what? A constant. This will be 0. I'll simply have it to be what? S, right? The r on the s is equal to s, right? So it's equal to t, because the s here will be 1. So I'll get a t here. So I'll multiply this by t plus, when I come here, the z on the theta, I'm differentiating the whole thing with respect to theta. So this function, I want to differentiate this function with respect to what? Theta. Theta here is a trig function, right? But once I'm differentiating with respect to what? Theta, my r becomes a constant. Take note. So I'll simply have this, which is what? 3 cos 3 theta times what? E to the power 2r. As simple as that. So I'll simply have 3 cosine 3 theta multiplying e to the power 2r. Then this inner function times the theta on the s. So the theta on the s is giving us, I have the theta on the s. I'm having square root of what? S squared plus t squared. This is the same as s squared plus t squared to the power negative 1 half, right? So it's the power half to the power half to the power half. So once I get this, to differentiate this with respect to what? S, I simply consider my t as what? A constant, but this is still a composite function. So I will differentiate the entire function as half s squared plus t squared negative half. Then you differentiate what is inside your s, so you get multiply by 2s. Okay, yes. So at this point, we need to further simplify our derivatives. So here I'm going to get 2t e to the power 2r sine 3 theta plus, when I come here, I'll get 3 cos 3 theta e to the power 2r multiply by multiplied by, so these two here will cancel the two here. I'll simply have s over the square root of what? S squared plus t squared. Because this is negative half, right? Yes, so that's how we got it. So at this point, the question asks us to find the z over the s. So we need to make substitutions, right? We need to make substitutions. Wherever you see our r, we put what is r there. Wherever you see our theta, we put what is theta there. So we simply get 2t multiplying e to the power 2. My r is st minus t squared sine 3 theta, where theta is equal to square root of s squared plus t squared plus 3 cosine 3 theta square root of s squared plus t squared multiplying e to the power 2, and the r is what? St minus t squared times x over square root of s squared plus t squared. And this gives us our ds on the, our dz on the x, right? So we move to the second part of the question, saying that you should find dz over dt. So for dz over dt, we come again to the function. The function is c is equal to e to the power 2r sine of the expression 3 theta, where r is equal to st minus t squared and theta is equal to the square root of st s squared plus t squared, like this. So the z on the t, where are my t's? My t's are within r and what? Theta. So I will have to access this t by opening what? R, or getting access to what? R and theta first. So I'm going to get the z on what? The r times the r on the t plus the z on the theta times the theta on the t, like this. So this is going to give me the z on the r, the z on the r. I'm going to get 2, I'm going to get 2 e to the power 2r sine 3 theta. So that's what we just did, right? Times the r on the t. So the r on the t is the only different thing here. So now I'm differentiating my r with respect to t. So with respect to t, s is a constant, right? So I'll get, if s is a constant, when I differentiate this st with respect to t, I'll get s, right? When I differentiate this minus 2t. That is all for this. Now plus the z on the theta. I'm differentiating this with respect to my theta. This becomes a constant. So e to the power 2r is a constant. Okay. Then when I differentiate this, I'll get what? Cosine 3 theta. But you just have to multiply here by 3. Then times the theta on the t. So the theta on the t. When I differentiate this with respect to t, I simply take s as a constant, right? So I said this is the same as s squared plus t squared all to the power half. So we simply multiply half by what? S squared plus t squared to the power negative half. Multiply by differentiating t squared alone, 2t. So this gives me 2 e to the power 2r sine 3 theta multiplied by s minus 2t plus 3 e to the power 2r cosine 3 theta. This cancels this. So times t over square root of s squared plus t squared, like this. So once we are done with our derivatives, we just have to make substitutions, right? So we get 2 e to the power 2 my r is st minus t squared sine 3, your theta is square root of what? S squared plus t squared, right? Then I'll have b multiplied by x minus 2t plus 3. Then I come here, e to the power the 2r goes again, st minus t squared cosine 3, and the theta comes as square root of what? S squared plus t squared times t square root of s squared plus t squared. So this is the end of this video. Thank you for being with me. Don't forget to like, subscribe, and share.